Now let's see the second source of power dissipation in CMOS circuit, and which is nothing but short circuit power dissipation. So short circuit power dissipation happens when, let's again assume the example of an inverter, and what will be the condition of short circuit power dissipation? Short circuit means the circuit is basically became a short. That means if this PMOS transistor is on and this NMOS transistor is also on, then there is a direct path from VDD to the ground. Basically it happened kind of short circuit. So if there is an input signal applied in such a way that this PMOS and NMOS transistor both became on for some time, in that particular time there is a direct path from VDD to ground and a very large spike of current will flow. So this current will cause again power, which is nothing but power dissipation, which is nothing but VDD into IDD, and this is also unnecessary power dissipation. This we are not expecting this. We are not expecting a situation where PMOS and NMOS transistor both can become on in an inverter circuit. But if the input voltage is applied in such a way that this PMOS and NMOS transistor both became on, there will be an unwanted very large spike of the current flowing in the circuit, and which is causing the power dissipation. Examples, we have applied a pulse at the input like this, and this is nothing but V threshold voltage of NMOS transistor, VTN. I will call it VTN, and then we have this voltage level, which is nothing but equal to VDD minus VTP. So guys, here if you see here the NMOS transistor is off, and when this voltage input voltage rises from 0 to VTH, after VTH threshold voltage of this NMOS transistor will become on, but the PMOS transistor is still on. The PMOS transistor will be off when the input voltage reaches VDD minus VTPMOS. When the input voltage is nothing but VDD minus threshold voltage of PMOS transistor, the input voltage reaches at this level, the PMOS transistor will be off. So in between this time, both the NMOS and PMOS transistor are on. That means during this time, there is a large current flowing through the circuit, which is nothing but short circuit current, and the power associated with this short circuit is nothing but short circuit power dissipation. So this is also by carefully designing the input and output load of the inverter circuit, we can minimize this power dissipation. We will see in further slides how we can do that, but first let's understand what are all sources in power dissipation in CMOS circuits, where the first power dissipation as we discussed is dynamic power dissipation. So dynamic power dissipation actually we cannot optimize completely, but we can minimize that, because the dynamic power dissipation occurs because of the functionality of the circuit when the circuit is doing some activity, and the short circuit power dissipation actually happens because if there is a direct path between supply voltage and the ground, then there is a large current spike flowing through the circuit, and that will cause the short circuit power dissipations. But that can be actually also minimized by carefully designing the input and output load of the circuit.